Welcome to the Gate Academy Power Pack class of Transportation Engineering. So as you know, Transportation Engineering holds a significant weightage in GATE exam. It holds almost 10% weightage in civil engineering paper, correct? So what we will do today, we will discuss 8 number of questions which can be asked for GATE exam from Transportation Engineering. Okay, so if you are attending the entire session of these 8 questions, you will get an overall idea regarding transportation engineering. Okay, and it will be very helpful for you when you are attending the GATE exam this year. Fine, so we will discuss 8 number of questions which will cover almost the syllabus of transportation engineering. Fine, so we will go to the first question now. You can see the question here. I will read it. The longitudinal gradient of a road is 1 in 20. If the radius of a horizontal curve on this road is equal to 30 meter, the grade compensation will be dash. Correct? So they have given 4 options also. 2%, 2.5%, 4% and 1%. So the grade compensation we have to find out in percentage, correct? So out of the given option, which is the correct option that we have to select. Fine. So in order to solve this question, first of all, we have to know what is the equation to find out the grade compensation, correct? So what is the equation for grade compensation? We know grade compensation is equal to minimum of 2 values, correct? 30 plus R divided by R and 75 divided by R. So we know this is the equation for grade compensation. We have to select whichever is minimum. So just read the question once again and check which all values they have given. They have given the value of R. R means what? The radius of curve, okay, that they have directly given. So from these equations, directly we will get what is the grade compensation value, correct? So what it will be, directly we will be getting in percentage. So this will be 30 plus R value is 30 meter. This will be 75 divided by 30 meter, correct? Because given that radius value is 30 meter. So what you will be getting? 60 divided by 30. Directly you are getting in percentage. Okay. So 75 divided by 30. You will get 2.5%. Okay. So from the equation what we are getting? It will be the minimum of 2 and 2.5. What it will be? 2%. Correct? So you may be thinking that from the option A will be correct. Okay? But we don't know whether it is the correct answer or not. Why? Whenever we are calculating the grade compensation, we have to do a check. We are having a rule as per IRC, Indian Road Congress. They have given us a rule. What is that rule? After applying this grade compensation on the existing gradient, we will get a resultant gradient. It is called compensated gradient, correct? After applying this grade compensation, what is the gradient we are obtaining as a result? It is called compensated gradient. So what is the rule given per IRC? As per IRC, we know the compensated gradient should not be less than 4%. Correct? After applying the grade compensation on the existing gradient, the resultant we are obtaining, which is called compensated gradient, it should not be less than 4%. Correct? So, after obtaining the value as per the equation, we have to check whether we are obeying the rule given as per IRC. Okay? So, what is the value of compensated gradient? I am representing it as CG, compensated gradient. Okay? What is the value of compensated gradient? Actual gradient. Actual gradient minus grade compensation. Correct? What is grade compensation? We are decreasing the gradient. We are decreasing the actual gradient, existing gradient, in order to minimize the loss. Correct? So, from the actual gradient, we are minusing some value and we are compensating the losses happening. So, that compensated gradient, we have to check whether we are obeying this rule given by IRC. Correct? So, what it will be? Actual gradient. They have given in the question, no? What is that? 1 in 20. So, 1 in 20 minus what we got? The minimum of 2 and 2.5. So 2%. I have to minus 2% from the existing gradient. So finally I should get in percentage. Correct? Because in options they have given the options in percentage. So I have to convert into percentage. However, so 1 in 20 I will get 0.05. What do you mean by 0.05? How to find out this 1 in 20? 1 by 20, correct? So I can write it as 5%. Okay? So it is nothing but 5% minus 2%. What I am getting? 3%. So check whether we are obeying the rule given by IRC. What is the rule? It should not be less than 4%. But if we are applying a grade compensation of 2%, we are not obeying. Correct? So the obtained value, we are not obeying the rule given by IRC. So what we have to do? What it means? We can't apply a grade compensation of 2%. If we are applying 2%, we are going against the rule. We have to obey the rule given by IRC. So what I have to do? They told that the minimum value is 4%. Less than that, less than 4%, we can't go. The compensated gradient, the minimum value is 4%. So if I want to limit the compensated gradient as 4%, what I have to do? This is fixed, correct? This 5% is fixed minus whenever I am applying the grade compensation, the minimum is 4%, correct? So how I can find out the grade compensation now? The existing gradient minus 4%. The existing gradient minus 4%. See, take it here. Okay. So what will be the value? 1%. Understanding? So the correct option will be, which is the correct option? Option D is the correct answer. Okay. So the question seems to be simple. Directly you will get the value from the equation, but always you have to check whether we are obeying the rule. Okay. So here the correct option is option D, which is 1%. Okay. See, suppose the given gradient, I am just changing the question for a better understanding. Suppose the actual gradient, instead of this 5%, they are telling actual gradient is say 8%. Okay, they are telling actual gradient is 8%. So instead of this 5, what I am getting? Compensated gradient is equal to 8% by, as per the equation, 8% by 2%. What I will get? 6%. Correct? So if I am getting 6%, am I obeying this rule? Yes, we are obeying. So no problem. We are obeying the rule. So grade compensation will be 2%. Okay. If it is going less than 4%, it should not be less than 4%. It should be always greater than or equal to 4%. If we are obeying, whatever value we are getting here is the final answer. If we are not obeying, we have to limit this value as 4% and find out then what can be the value of grade compensation. Okay. So the same question they can ask, what is the value of compensated gradient? Okay. What is the value of compensated gradient? Like that also they can ask. So one option definitely will be 3%. So if you don't know the rule, what you will do? We'll tick 3%, we'll select 3% and move on. Okay. So what you should do? You should remember this rule. So if they are asking, instead of asking grade compensation, if they are asking compensated gradient, if it is going less than 4%, you have to set it as 4% only. So in this question, what is the value of compensated gradient? 4%, and grade compensation is 1%. Okay. Hope you understood the concept. Just go through the solution once again and be thorough with the concept. First thing, you should know what is the equation for grade compensation. And the next thing, you should remember what is the rule as per IRC, Indian Road Congress. What is the rule? The grade, after applying grade compensation, whatever gradient we are obtaining, it should not be less than 4%. If it is going less than 4%, we should limit the value as 4% and proceed. Okay. So seems to be simple question, but a tricky question. So whenever they are giving the actual gradient value, you should check this. Okay. If they are not giving any value for the existing gradient, they are giving only the radius value, then we can't check anything. So whatever value you are getting, it will be the answer. If they are giving any existing gradient value, then always you have to check it. Okay. So hope you understood the concept. Now we will move on to the next question. So just read the question. A vertical summit curve is formed at the intersection of two gradients, plus 3% and minus 5%. The design speed of this single lane two-way road is 80 km/h. Find the length of summit curve required as per stopping sight distance criteria. They have also given that the coefficient of longitudinal friction is equal to 0.35. Okay. So let's read the question and understand what we have to do and what all data they have given, what all values they have given, and what we have to find out. They asked the length of summit curve, correct? So if you want to find the length of summit curve, we should know based on which criteria we have to design it. Okay. So read the question, which criteria they have given. They have given that based on stopping sight distance criteria we have to find out. Correct. So what are the design criteria for summit curve? The design criteria is sight distance. The sight distance can be either stopping sight distance or overtaking sight distance. Overtaking sight distance, if we can't provide that, intermediate sight distance also. Okay. So based on the sight distance only, we are finding the length of summit curve. Correct. So what is the equation for finding out the length of summit curve for our stopping sight distance criteria? We are having two conditions, correct? What is the first condition? If the length of curve is greater than safe sight distance. If the length of curve, I am representing it as L, length of summit curve. If it is greater than the safe sight distance, so in this case, safe stopping sight distance, we are having one equation. And if the length of this summit curve is less than the safe stopping sight distance, we are having another equation. So here, whether they have given any condition? No. Then what do we have to do? Always we have to assume that L is greater than S. Okay. So first I will give you just both equations just to refresh your memory. So if length of curve is greater than safe stopping sight distance, what is the equation for L? L means what? The length of summit curve. It is ns square divided by root 2h plus root 2 small h whole square. Correct? I will explain each term. So this is the equation if the length of summit curve is greater than stopping sight distance, safe stopping sight distance. And if L is less than S, what is the equation? 2S minus root 2h plus root 2 small h the whole square divided by n. Okay? Always remember this divided by n is for only this part. 2s is different, this whole section is different. Okay? It is not whole divided by, it is just for this part. Okay? So here either they can give you a condition. They will give you the length is greater than safe distance or length is less than safe distance. So they can give any condition. If they are not giving, by default we have to assume the first criteria and move on. Finally we will check whether our assumption is correct or not. Okay? So since they have not given any criteria, any condition, among this we will proceed with the first equation, assuming that the length of our summit curve is greater than the safe sight distance. So in this case, greater than safe stopping sight distance. So I am eliminating this equation and I am assuming that this equation we have to use, and I will proceed. After obtaining the value, I will check whether my assumption is actually correct or not. Fine. So, in this equation, what is n means? N is the deviation angle. Correct? How to find out the deviation angle? The first gradient minus second gradient, and we will take the modulus value of that. Correct? So, what is the given question? A plus 3% gradient is meeting a minus 5%. What is that plus and minus indicates? It indicates that whether it is an upward curve or it is a downward curve. Correct? Plus 3 means what? A curve is going upward. The gradient is upward. What is the gradient? 3%. This plus indicates that it is an upward gradient, and it is meeting a minus 5% gradient, means a gradient downward, which gradient is 5%. Since it is downward, we are representing it as minus. Okay. So what is the value of deviation angle? The first gradient minus second gradient. So plus 3 minus 5. So you will get 8%. Correct? See, actually no need to do all these things. Whatever value they are giving, you can just take the sum of that. Getting? Means no need to consider the sign. Here it is 3 and here it is 5. The gradient value. So the modulus value you can take directly, you can take the sum. You will get the correct answer only. So no need to waste the time. At least 5 seconds you can waste. You will get here. Correct? No need to waste. So either you can do like this, or no need to waste time. Take the modulus value, that is 3. Here 3%. Here it is 5%. So n will be 3 plus 5. It will be 8%. If it is a summary curve or valley curve, whatever it is, you can just take the sum of the modulus value. If it was a valley curve, finally you will get minus of some value, but we are taking the modulus, correct? So finally you will be getting the exact value. So either you can do like this, or simply you can add the modulus values 3 plus 5, 8%. Okay? So how I should write it as? In decimal. In equation, we will not use the percentage, we have to substitute 0.08. Okay? So this is done. Then we have to find out what is the value of S, capital H and small h. Then substitute in the equation, the length is find out. Okay, what is S? It is the safe sight distance. So in this question, what is sight distance? Stopping sight distance they have given. Sometimes they can ask you overtaking sight distance also. Then different equation. In that equation also we are having S. There it will be overtaking sight distance. So in this question they have asked based on stopping sight distance we have to find out. So I want to find out what is the value of S. S means what? Safe sight distance. So since they have asked for stopping sight distance, first I have to find out what is stopping sight distance. What is the equation? Vt plus v square by 2gf, where v is the speed, t is the reaction time, j is nothing but the acceleration due to gravity, f is the coefficient of longitudinal friction. So always remember, the stopping sight distance means what? It is in longitudinal direction. So the f value will be coefficient of longitudinal friction. We are having one more friction. What is that? Coefficient of side friction, or it is also called coefficient of lateral friction. See, in this question they have only given one value, which is coefficient of longitudinal friction. Sometimes they can give you both the values just to check whether you know which value of coefficient of friction you have to take. So they can also give you the value of coefficient of lateral friction also. So you should know, in stopping sight distance, what is happening? We are stopping in the longitudinal direction. So always you have to take coefficient of longitudinal friction. Okay. So just find out the value. Here the speed should be in meter per second. Why? This t, reaction time, definitely it will be in seconds only. And similarly here also g is 9.81 meter per second square, correct? So every term we have to set it in the same unit. So we will set in terms of meter and second. So v value, what value they have given? They have given it as 80 km per hour, correct? So in every question, definitely they will be giving the value of speed in kilometer per hour only. Why? Generally we will express the speed of a vehicle in kilometer per hour, correct? We will not tell the speed of this vehicle is this meter per second. We will not tell generally, correct? So most probably they will be giving the value in kilometer per hour only. So always we have to convert this value which is in kilometer per hour into meter per second. How to convert kilometer per hour into meter per second? This kilometer per hour we will multiply by 5 by 18 in order to obtain meter per second, correct? So whatever value they have given in kilometer per hour, multiply with 5 by 18 and obtain the value in meter per second. So 80 into 5 by 18 you will get 22.22 meter per second. Correct? So don't try to round it off. At least take 2 decimals everywhere. Why? Because see here you are using your value, and again this value you will be substituting here. Correct? So if it is a final answer, you can round it off. Otherwise, don't try to round it off. Take the at least 2 decimals you take and proceed. Why? Because if you are rounding there itself, your final answer may have some change. Okay? So no need to take risk. Sometimes they will give you a range. So sometimes if you are rounding it in the first stage itself, there is a chance to go out of the range. So don't try to round it off. At least you take 2-3 decimals and move on. Okay? So what will be the value? So the stopping side distance will be speed into reaction time. What is the reaction time? Whether they have given any value? No. Whenever they are not giving any value, what we have to take? We are having some value as per IRC, correct? So what is the reaction time as per IRC? 2.5 seconds, correct? So as per IRC, the reaction time for stopping is 2.5 seconds. You have to remember that. Very important point. That value is asked for GATE exam also, just for 1 mark. Okay. So you need it in numerical problems as well as in theory also. They can ask you what is the value of reaction time for stopping. Okay. Remember, it is for stopping. If it is for overtaking, it is 2 seconds. For stopping, it is 2.5 seconds. Okay. Plus V square divided by 2 into 9.81, which is the acceleration due to gravity. F value, what value they have given? They have given it as 0.35. Okay. So if you are substituting the values, you will be getting 127.45 meter. So whether it is the value of S or not, that also I have to check. What is S? It is the safe stopping side distance. So I have to check whether this value will be equal to the safe distance or not. For that, what we have to do? We have to check the condition of road, whether it is 1 lane or multi-lane, whether it is 1 way or 2 way, correct? Based on that, the value of S may change, correct? So what is the special case for us? If a lane is there which is a single lane, and that single lane is 2 way. If a single lane is there which is 2 way, this is a special case. So a single lane 2 way means what? In both directions vehicles are coming. In both directions vehicles are coming exactly like this, face to face. Then the stopping side distance should be always get multiplied by 2, so that this will be the value of safe stopping side distance. So this is our special case. If it is a single lane 2 way, then S value will be equal to 2 times the calculated stopping side distance, and we have to multiply by 2 only if it is a single lane 2 way road. So check our question whether it is this condition or not. If it is this condition, we have to multiply. If it is not, no need to multiply. Whatever value we have got, we can substitute for S. So check the question. They have given that it is a single lane 2 way road. So always we have to read the question very carefully and check whether the condition is this one or not. So in this question, this is the condition. So we have to multiply the obtained value of S with 2 to obtain the safe sight distance. safe stopping sight distance. It will be 2 into 127.45. You will get approximately 225 meter. Correct? 224.9 meter you will get. Okay. So now I got the value of S. See, suppose if it was not a single lane two-way, then S value will be 127 only. 127.45 only. But in this case, they have given it is a single lane two-way road. So such sentence you should be take care of. So the safe stopping sight distance will be 2 times the calculated stopping sight distance. So what value I am getting? S is equal to 225 meter. Okay. So the numerator part is done. N I have find out. S value I have find out. So S value square I have to take. Don't forget S value square. Now the denominator part I have to check. H is there, small h is there. What are these terms? That you should know. What is capital H? Whenever you are driving your vehicle, you will be sitting. So your eye will be at a particular height from the ground level. Correct? From the ground level or from the road surface. What is the height of your eye level when you are driving your vehicle like this? Your eye level will be at a particular height. So depends on the type of vehicle, it may get changed. Okay. So there will be there can be different values. Okay. So sometimes they will give you in the question, but most probably they will not give. Most probably they will not give the value of this capital H, the height of your eye level from the road surface. Check in this question whether they have given. No. So whenever they are not giving, what is our option? There will be a value given by IRC. Correct? So as per IRC, this H value is 1.2 meter. As per IRC, the capital H value, the height of, we can say the average height, because it can be any value, correct? So the average height of eye level above the road surface as per IRC, it is 1.2 meter. So I have to substitute 1.2 here instead of H, capital H. Now we are having small h. What is that small h? It is the minimum height of the obstruction. See, why we are stopping our vehicle? Whenever we are finding some obstruction in our way, correct? Suppose there is a paper on the road, a paper from the book. Somehow it is there on the road. Will you stop your vehicle? No, definitely not. Why? Because we know it will not going to affect our vehicle. Why? Because it is only less thickness. So the height of that object matters, correct? So IRC says that we will stop our vehicle only if the obstruction is having some particular height. That height is called as small h. That height denoted as small h. It is the minimum height of the obstruction, so that we will stop our vehicle. Whether they have given any value in the question? No, they will not give. Why? Because there is a particular value given as per IRC. So they are demanding us to know that value. What is that value? Small h is equal to 0.15 meter or 15 centimeter. Okay, height of a small scale, 15 centimeter. So we have to substitute everything in meter, no? So 0.15 meter. Okay, so I have obtained everything. N value I got, S value I have obtained, capital H and small h I know. If not given as per IRC, what are the values? That also we know. So finally we can substitute, correct? So N is equal to 108 into, what is S value? 225. Don't forget to put the square. divided by root of 2 into 1.2 plus root of 2 into 0.15 the whole square. Okay, that we have to calculate. See, I told you most probably 99.9% they will not give the value of capital H and small h. So definitely we have to substitute those values of 1.2 meter for capital H, 0.15 meter for small h. So every time we may be substituting those values only. So no need to substitute and try what is the value in the exam hall. No need to waste time, correct? Because we know most of the time it will be 1.2 and 0.15. So now itself we can substitute and find out the value so that we can mug up what is that value. Because in the exam hall, no need to waste time. See, in the virtual calculator, if you are substituting those values, you will lose so much time in the virtual calculator, correct? So if I am substituting 1.2 here instead of capital H, 1.2 meter, and if I am substituting small h is equal to 0.15 meter, I will get this denominator part will become 4.4. Okay, so what equation you can find out, you can mug up, it will be ns square divided by 4.4 if that capital H and small h are not given, which means if that capital H and small h are 0.12 meter and 1.2 meter and 0.15 meter. Okay, so this will be the value 4.4. Try to mug up this because you can save lot of time. Fine. So direct substitution of every values. So if you are substituting, you will get a value 1182 meter. So this will be the final value. But here also the procedure is not ended. What we have to check? See, initially we have made an assumption, correct? So what was that assumption? Our length of curve is greater than the stopping sight distance, correct? Based on that assumption only, I have proceeded with this equation, correct? So now what I have to do? Whether the assumption we have made initially, what is S value? 225. Whether it is okay or not, that we have to check, correct? Whether it is okay. Yes, the L value is greater than safe. So whatever assumption I have made is correct only. So the final answer will be 1182 meter. Suppose this condition we are not satisfying. What it means? After calculation, we got some value of L which is less than S after checking. Okay, after obtaining the value of length of semicurve, we found that it is less than the safe stopping sight distance, which means the assumption we made initially was actually wrong. Based on that wrong assumption only, we have calculated the value of L. Then what will happen? Whatever value we have obtained will become wrong. Then what we have to do? This assumption will become wrong. Then the next thing, what means? Actually, the L was less than S. If you are obtaining the assumption as wrong, if you are obtaining the L value less than S, which means the assumption we made was actually wrong. Okay, so now we understood that the L is less than S. In this particular question, this is the final answer. I am giving you some extra points, okay, for your knowledge. Suppose if you are getting less value, what we are understanding, the assumption was wrong, so L will be less than S. Then what you have to do? Whatever value you have obtained is absolutely wrong, and we will eliminate that value. We will take the next equation. What was that? 2s minus root 2h plus root 2 small h square divided by n. Okay, so we will substitute the values. Now we will find out the actual value of length. Okay, that will be less than s only. Okay, so this is how we have to proceed. Okay, just check what all things we have done. First thing, you have to remember the equation for length of summit curve, and also in the equation, the very important thing, there are two assumptions are there. Based on the assumption, you have to take the equation, and if the assumption is not given, you have to assume it is first one, and we will proceed. If you are getting something against our assumption, we will use the second condition. Okay, and one more thing, in stopping side distance, you have to remember the value of reaction time. Most probably they will not be giving. And one more thing, always we have to substitute the value of speed in kilometer per hour from meter per second. You have to convert the value into meter per second. Okay, and these values also, the capital H will be 1.2 and small h will be 0.15. Why you should remember that? Maybe for 1 mark they can ask those questions. Okay, so if you are substituting capital H is equal to 1.2 meter and small h is equal to 0.15 meter, you will get that denominator part as 4.4. So you always remember that. Why? Because if you are remembering that value of 4.4, you can save a lot of time in the examination hall. Okay, because you are using virtual calculator there, the online calculator there. You are not using your scientific calculator. Okay, so try to remember that value 4.4. Okay, so hope you have understood this question. Now we will move on to the next question. Okay, so let's read the question. A horizontal curve of radius 480 meter for a 2-lane road of width 7.5 meter is to be designed for a speed of 80 km per hour. The value of raising of the outer edge of the pavement with respect to the ground level for mixed traffic condition will be dash meter. And they also mentioned that the pavement is rotated about the center. Okay, so finally what they have asked, read the question carefully and understand what they have asked. Read the question carefully and understand what they have asked and what are the given condition. Okay, so hope you have gone through the question. So what they have asked, what is the raising of the outer edge? What is the raising of the pavement with respect to the ground level? So we know that it is something related to super elevation, correct? The raising of the edge of pavement is called as super elevation. We are having a pavement which is level on the straight road surface. Okay, camera will be there on the horizontal curves. What we will do? We will raise the edge. We will raise the outer edge of the pavement in order to make a slope, correct? A transverse slope, which is called super elevation. So in whichever way we can make super elevation, we are having different methods to attain super elevation, correct? Suppose if it was the horizontal ground, either we can raise the outer edge or lower the inner edge and make the slope like this. Make the road like this, correct? So we are providing a slope like this. So this is one method of attaining the super elevation. we are raising the edge at a height of capital E, so that this width will be B. Okay. So what is the value? What is the equation for super elevation? The raising divided by width. Correct? The raising divided by width is the equation for super elevation that we know. Correct? So also this is one method, raising or lowering the edge. Other method is what? We can rotate about center. Correct? If you are rotating about center, how I can draw that? See, half height I will raise here. That is, total height is E. Half height E by 2 I will raise here, and I will lower E by 2 in this side. So finally I will get the whatever inclination I need, I will get it. Okay. So this part will be E by 2 and this part will be E by 2. So we are rotating about this center. Correct? We are raising a distance of E by 2. Here also E by 2. So the total height will be E only. So there also the super elevation we are obtaining in different way. Okay. So in this question they told that the pavement is rotated about center, means this is the given case. Correct? That is the given case. Whatever the super elevation E will be E by B. Okay, the raising divided by the horizontal width. Okay. Now, what they asked, what is that height? In order to find out what is this value, what is this E by 2, that we have to find out, right, as per the question. So, if I want to find out what is that raising, I should know what is the value of this capital, this small e, that is the super elevation. What is the value of width? B means what? Width of the road. So I should know what is the value of this super elevation, rate of super elevation, small e, and what is the width of the road, which is denoted as B. So if I know this value, I can find out what is that raising height. Correct? So I should know how to calculate the value of super elevation. So we will check what are the equations available for finding out the super elevation. So we are having a general equation. What is that? E plus F is equal to V square by RG. Correct? This is the general equation for super elevation, where this V is in meter per second. If I am substituting it in kilometer per hour, what will be the equation? Capital V square divided by 127 R. Correct? That is, instead of putting it in meter per second, directly I can take the value from the question and I can use this equation, V square by 127 R. Same value we are converting into kilometer per hour, and we are substituting, we are applying the value of acceleration due to gravity, which is 9.81. Correct? So if I am applying everything, I can use this equation, which is V square by 127 R. I will recommend you to remember this equation. Why? Because directly you can apply. Definitely in the question, they will be giving the value in kilometer per hour only. So directly we can apply. No need to convert into meter per second again and divide by 9.81. No need to waste your time. Okay. So that is the general equation. So sometimes they will just twist the question. They will just use some technical terms so that the equation will get some modification. Okay. I will tell you what are those modifications when we have to give those modification in the general equation. Okay. We are having two terms. Equilibrium super elevation. Equilibrium super elevation and design super elevation. equilibrium superelevation and design superelevation. What is the difference if they are mentioning it as equilibrium superelevation, and what is the difference if they are mentioning it as design superelevation? Instead of simply telling to find out the value of superelevation, they will use some difference. Okay, equilibrium superelevation, what we will do? We will assume F is equal to 0. Both case we will assume F is equal to 0. Then what will be the value of E equilibrium? F is becoming 0. So you can write V square by 127 R. Okay. So we will not take the coefficient of friction into consideration if they are mentioning it as equilibrium superelevation. What is equilibrium superelevation? When both the pressure on the outer wheel and pressure on the inner wheel are equal. It is called equilibrium superelevation. The next thing is design superelevation. So sometimes they will use the term the superelevation for mixed traffic condition. The superelevation for mixed traffic. So if they are using this term in the question, which actually means they are asking you the design superelevation. So in this design superelevation also, we'll assume we'll take the value of F as 0, and also we will take the speed is 75% of design speed. 75% of design speed. Okay. So what I can write, E design is equal to, instead of V square by Rg, I have to take 0.75 V divided by Rg square. 0.75 V square divided by Rg. So I can write it 0.5 square into small v square by Rg. I can write it as capital V square by Rg. Capital V square by 127 R. So I can write it as V in kilometers per hour square divided by 225 R. Okay, this is what? Design superelevation. Okay, so we are having general equation for equilibrium superelevation, equilibrium for design superelevation. So based on the question, we should understand which equation we have to use and substitute in that equation. Fine. So check the question once again, whether they have mentioned anything, equilibrium or design or superelevation for mixed traffic, anything they have mentioned or not. Yes, they have mentioned that for mixed traffic condition. Correct? So which equation I have to use? Whether general equation or equilibrium or design. We have to use this equation in order to find out the value of superelevation. Correct? So I am proceeding with this equation, V square by 225 R. Understood? So I am eliminating all these equations. I am eliminating the general equation, the equilibrium equation, and finally I am taking the value for design superelevation. Since they have mentioned it is, we have to find it for mixed traffic. Correct? So V square by 225 R. Okay. So what is the value of V? V is in kilometer per hour. Correct? They have given the value as the design speed is 80 kilometer per hour. So 80 square by 225 into radius of the curve. What is the value of radius? They have given it as 480 meter. So I can substitute. So if you are substituting the values, you will get E is equal to 0.059. Okay. So the value of E, you got it as 0.059. See, one important point which you have to remember, you got a value of superelevation. There we have to check whether we are obeying the rule as per IRC. Here also a rule is there. What is that rule? The maximum value of superelevation. We have to check whether it is below the maximum value. We shouldn't increase the inclination as we wish. There is a maximum limit as per IRC. So if it is going beyond the maximum limit, we have to limit that in that limit, correct? In that value. So what is that value? You should be always less than or equal to the Emax. What is that value? For Emax, 7%. For plain and rolling terrain, if they are not telling anything regarding the type of terrain, it will be rolling terrain or plain terrain. So for both, we'll assume, if they are not giving, we'll assume that it will be a plain or rolling terrain, and the value, maximum value is 7%. Suppose it is a hilly area, then that value is 10%. Okay, take this knowledge. Also, if they are not giving the type of terrain in the question, we'll assume that it is a plain or rolling terrain. So the Emax value is 7%. So I have to check whether I am obeying this rule or not. Okay, so this is in fraction. So 7% means what? 0.07. Whether it is okay? Yes, it is well below the Emax value. Then the E value is 0.059 only. Okay. In case we are going beyond 7%, we have to set our value as 7%. The final answer will be 7% for superelevation. If we are going above Emax value. Okay. So I got my rate of superelevation small e is 0.059. Okay. But what they have asked, this is not the final answer. What they have asked, what is this raising of the edge with respect to ground if it is rotated about center, correct? So I know E is equal to total raising divided by width of the road. Whether they have given any width? Yes, they have given that. It is 7.5 meter. Okay. So 0.059 is equal to the raising, the total height divided by 7.5. So E I can write it as 0.59 into 7.5. Whether this is our answer? No. This will be our answer if it is rotated about an edge. But here it is told that the pavement is rotated about center line. Correct? About the center of the road. So this is what is asked. What is that? It is E by 2. So the total raising will be E by 2 divided by 2. Correct? So this much height we are raising above the ground, and that much height we are lowering below the ground. So if you are substituting, you will get 0.22 meter. That is 22 centimeter we are raising here. 22 centimeter and 22 centimeter we are lowering here. Understood? So what is the final value? 0.22 meter is the final answer. Okay. Hope you have understood the solution. Just go through the solution once again and what all things we have done, and be thorough with the concept. Just go through it. Just go through the solution once again. What you have to do? First we have to understand what are the given conditions, how the superelevation is attained, either this one or that one. The second thing, very important thing, which type of superelevation they have asked. Which type in the sense whether it is design superelevation or whether it is equilibrium superelevation or whether we have to use the general case. If they are not mentioning anything like design superelevation or for fixed traffic or mixed traffic or equilibrium superelevation, or they are not mentioning the pressure on inner wheel is equal to outer wheel. If they are not mentioning anything, then we have to use the general case. Fine. And what is that E value? It will be equal to the total vertical height divided by the horizontal width of the road. Okay. Hope you understood that. And now we will move on to the next question. Okay. So let's read the question. A two-lane road is to be constructed in a place of heavy rainfall. Okay. If the road is of bituminous type, what should be the height of crown with respect to the edges of the pavement? A two-lane road and it is constructed in a place of heavy rainfall, and they told that the road is of bituminous type. The road can be of cement, concrete, macadam, anything. They told that it is of bituminous type, and what should be the height of crown with respect to the edges of the pavement. Okay. So if you are taking the cross section of a road, if this is the width of the road, how will be the surface? It will be like this. Correct? This inclination is called a camber. Correct? This inclination is called a camber, which is represented as 1 in n. What is the height? What is the height when we are moving n horizontal unit? Correct? So this the camber we are represented it as 1 in n. Okay. Finally, they have asked what is the height of crown. Crown means what? At the center here. Correct? So they asked what is this height? The height of crown with respect to edges. That is, with respect to this line, what is the height of crown? From the edge, what is the height of that point? That what they have asked. Correct? So we know at any height, at any horizontal distance, x. See, suppose I am taking a point here. That is this point. Instead of crown, I am taking some other point which is at x distance. So if I am representing it as some y distance, how we can find out the value of y? Y is equal to 2x square divided by nw. Okay. The height of any point on the road surface, y is equal to 2 times x square, the horizontal distance from the edge to that point, divided by n into w. What is n? The camber is what in n. Then what is the value of n? What is w? W is the width of road. W is width of road. So that is the equation for the height of any point on the road. Now they have asked what is the height of crown. So I am just representing it as the height of crown. C. Okay. So if I want to find out the height of crown, what I should do? The x value I should substitute. Correct? So height of crown means it is at the center of the road. So till center, what will be the width? The x value will become width by 2. Correct? X value will become, so this is the total width. So X value will become width divided by 2. So if I am substituting 2 into W by 2 squared by NW, what you will get? YC is equal to W by 2N. So this is the equation for height of crown. So now I have to substitute what is the width of the road and what is the value of N. If the camber is 1 in N, then that particular N value, 1 in what? That value I have to substitute here. Correct? So directly I will get what is the value of height of crown. So check whether they have given any value for width of road. No, they didn't give. Whether they have given any value for camber, that also they didn't give. So we don't know what is the value of W and we don't know what is the value of N. So how to find out the value of W and N? See, what is W? It is the width of road. So what will be the width of road for different conditions? Condition means if it is a single lane, what is the width? If it is multi-lane, what is the width of the road? So if it is a single lane road, what is the width? I will write here just for your knowledge. If it is a single lane, the width will be 3.75 meter. 3.75 meter. If it is a multi-lane, then what is the width? N into 3.5 meter, where N is the, not that N is the number of lanes, or I can just write number of lanes into 3.5. So in this case, what they have given? How many lanes are there? It is a 2-lane road, correct? So for 2-lane road, what will be the width? 2 into 3.5, it is 7 meter. Understood? Suppose it was a 4-lane road, then 4 into 3.5, 14 meter will get. If it was a single lane road, then not 1 into 3.5, for single lane we have to take 0.25 extra, 3.75 meter. So in this condition, they told that it is a 2-lane road, which means the value will be 2 into 3.5, which is 7 meter. So the numerator is okay. Here we got 7 meter. Now I want to know what is the value of N. How can we find out the value of N? In order to find out the value of N, we are having a standard table given by IRC. So you have to mug up that table. Okay. So I will give you that table here. So if you haven't noted this table before, just note this now. It is very important. So for different type of road, we are having different values for camber. Camber we represent it as 1 in N. And what is the value for camber for heavy rainfall? And what is the value of camber for less rainfall area? What is the value of camber in areas having heavy rainfall? And what is the value of camber in areas of less rainfall? See why this matters, whether it is heavy rainfall or less rainfall. The camber, why we are providing camber? Why we are providing this slope? For drainage purpose. Whenever rain is coming, we have to take this water away from the road, this sidewise. There will be side drains. We have to give some provision for the rainwater to escape to the side drains. So for drainage purpose only, we are giving camber. So whether heavy rain is there, whether less rain is there, that actually matters. Correct? If heavy rain is there, more slope you have to provide. If less rain is there, comparatively less slope is okay. Correct? So, if it is a cement concrete pavement, CC means cement concrete pavement, the value of camber is 1 in 50, and if it is less rainfall, it will be 1 in 60. If it is a bituminous pavement, means the quality of pavement is decreasing. If the quality of pavement decreasing, will provide more slope. Okay, so it will be 1 in 40 and 1 in 50. If it is a water-bound macadam, we will provide 1 in 33 and 1 in 40. And if it is an earth road, we will provide 1 in 25 and 1 in 33. Okay, so this table you have to mug up. So you can take values from this table not only for 2 marks question like this, also they will directly ask you what is the value of camber for some type of road in heavy or less rainfall area. Okay, if you are referring the previous question, you can find that such questions has been asked before. For 1 mark, they will directly ask you what is the value of camber. See, I am just giving an example. What is the value of camber for a cement concrete pavement if it is to be constructed in a less rainfall area? Then camber value is 1 in 60. So they have asked for 1 mark such type of questions. So if you are remembering this table, you will get questions for 1 mark as well as such questions which will be asked for 2 marks. There also you need the value. Okay, so this is 1 in n. Okay, so the n value means that right hand side value. The camber means what? It is a slope. 1 in that value. Okay, so from this table we can find what value we have to substitute here for this n. So check which type of road it is. They have given it is bituminous type. Correct? So I understood that this is the case. Now I want to know whether it is constructed in a heavy rainfall area or whether it is in a less rainfall area. So check the question. They have mentioned that it is in heavy rainfall area. So for bituminous heavy rainfall, what is the camber value? 1 in 40, which means 1 in n is equal to 1 in 40. So what is the n value? 40, correct? So now I can substitute YC is equal to, what is W? 7 meter divided by 2 into 40. So what value you will be getting? 7 divided by 80, it is equal to 0.875. 0.87 meter you will get. Okay, so as per the equation, as per the options, they have given the values in centimeter. Correct? They have given the values in centimeter. So I have to take it in centimeter. Correct? So it is 0.087. Okay. So as per the given options, which will be the correct answer? Option B will be the correct option. Correct? So we will get option B as the correct option. Okay? Just go through the solution and check what all things we have done and understand the concept carefully. Just go through the whole solution, what all things we have done. Seems to be a small question, but we have to remember a lot of things. But once you remember the table, it will be very advantageous. You can solve, you can attend some 1 mark question as well as it will be useful in 2 marks questions as well. Okay, so simple equation, simply you will get 2 marks if you are remembering the table. Okay, so just go through the solution once again and understand the concept. So what all things you have to do? First thing, you should know how to find out the height of camber. Okay, y is equal to 2x square divided by nw, and crown means at w by 2. So no need to substitute again and find out the equation in exam hall. Instead of that, you can remember this equation directly, because most probably they will be asking you the height of crown only. The other points they will not be asking. So directly you can remember this equation w by 2n, so that you can save your time. Fine. So w by 2n is the height of crown. What is that position? What is the height of that middle portion, the topmost portion with respect to edges? So in order to understand that, in order to find that, you should know how to calculate the width of road for single lane and for multi-lane, and you should remember the value of camber for various types of pavements and for various conditions. What are the conditions? Whether it is constructed in a heavy rainfall area or whether it is constructed in a less rainfall area. Okay. Now we will move on to the next question. Okay. Let's read the question. The relationship between speed u and density k for a traffic stream is found to be u is equal to 80 minus 0.8 k. The capacity of the traffic lane for this case will be dash in vehicles per hour they have asked. Okay. So the relationship between speed, which is in kilometer per hour, and density k, which is in vehicles per kilometer, they have given it as u is equal to 80 minus 0.8 k. Correct? So, and using this equation, using this expression, or the relationship between speed and density, we have to find out what is the value of maximum number of vehicles that can be come per hour. Correct? So we can proceed the solution in multiple ways. Okay. First, I will give you a conventional method. Second method also, it's somewhat a conventional method. Third method, I will give you a shortcut. Okay. So first we will see a conventional method of doing this problem. Fine. So what they have given, u is equal to 80 minus 0.8 k. Okay. 80 minus 0.8 k. This is the given expression or relationship between u and k. Now we want to find out what is maximum value of flow. Flow means vehicles per hour. Fine. So we know that flow, which is represented as q, is equal to speed into density. Correct? Flow is equal to speed into density. So I can write it as q is equal to, what is u? 80 minus 0.8 k. That value into k. So what I will get for q? 80 k minus 0.8 k square. Correct? So this expression I will get for q. So I got it as q is equal to 80 k minus 0.8 k square. See, whenever we want to maximize a quantity, whatever be the subject, whatever be the concept, okay, whenever we want to maximize a quantity, what we have to do? We will differentiate that quantity and equate it to 0. Whichever be the subject, whichever be the topic, whenever we want to find the maximum value, what we will do? If we want to maximize this value, what we will do? We will differentiate with respect to the variable. What is the variable here? K. So I will differentiate this expression, this Q, with respect to the variable K, and I will equate it to 0 whenever I want to maximize the quantity. Okay. So what I will be getting? D by dk of this expression. So I will get 80 minus 2 into 0.8. It will be equal to 0. So what I can write for K? It will be 80 divided by 1.6. 80 divided by 1.6. What value you will get? 50. Okay. You will get 50. So you got it as K is equal to 50 when we are maximizing the flow. That is, if I am substituting this value in this expression, I will get Q max, which is nothing but the maximum flow, the capacity of the road. Correct? So capacity, what will be capacity? Q maximum is equal to 80 into, substitute the value of K in the expression, 50 minus 0.8 into 50 square. So if you are substituting, you will get 2000 vehicles per hour. Okay. So which is the correct option? Option D will be the correct answer. So this is one way of doing the question. Okay. In two more methods we can proceed. So I will, this I can take as the method 1. Okay. Now I will show you the second method. Okay. You can select whichever method you want to do, whichever method you feel comfortable, you can do that. Okay. Now, so we know that U is equal to 80 minus 0.8 K. So this is the given expression. Now, as per green shield equation, we are having some equation for maximum flow, correct? What is that? Q max is equal to Vf into Kj divided by 4. Correct? This is as per green shield. Correct? As per green shield equation, Q max is Vf into Kj divided by 4. What is Vf? What is Vf? The maximum speed, that is the speed at free flow condition. No other vehicles are there to disturb us. Then we can go at a very high speed, the maximum speed. We are free in the stream. We are free to flow in the stream. So that value is called Vf. We denote it as Vf, which is the free flow speed. Kj means what? K at jam condition. What is the density at jam condition? In a jam condition of the road, how many vehicles are present in the road per kilometer? That we represented it as K suffix J. J represents jam condition. Okay. Now, if I am obtaining the value of Vf and Kj, I can directly substitute in the equation and find out what will be the maximum value of Q. Correct? Now, this Vf is what? The speed at free flow condition. So I am checking that condition. So at free flow condition, the speed I can represent it as Vf. Correct? So at free flow condition, what is happening? There are no other vehicles to disturb us. Correct? We can go at any speed. So the density will be almost equal to 0. There are no vehicles present. Only we are moving. Correct? So almost it is equal to 0. If no vehicles are there, at what speed a vehicle can go? So using that equation, U is what? speed. So I can represent it as Vf equal to 80 minus 0.8 into 0. Correct? So what you will get? Vf is equal to 80. Okay? So I got Vf. Now if I am finding the value of Kj, I can substitute and obtain the value. Correct? Now Kj means what? At jam condition. At traffic jam condition, what is happening? The value of speed. In jam condition, what is the value of speed? It will be almost equal to 0. Correct? So what I can write? U will become 0 is equal to 80 minus 0.8 into K. K at jam condition. How we will represent it? Kj. Okay. So what I am getting? Kj will be equal to 80 divided by 0.8. I will get 100. Okay. So I got the value of Vf and Kj, the free flow speed and jam density. Now I can substitute in this equation. Correct? So I am substituting the value of Vf and the value of Kj in this equation. So what I will get? Qmax is equal to, what is Vf? 80 into 100 divided by 4. I will get 2000 vehicles per hour. Correct? So this is the second method of doing the question. Okay? So exact answer we are getting 2000 vehicles per hour. Okay? So whichever method you feels comfortable, you can proceed. But I will give you one shortcut method also. Okay? One shortcut method so that it will be, seems to be simple. Fine? Now, the shortcut method. Okay? The shortcut method you can proceed once you know some concept. Okay? So this equation we are getting as a result of Greenshield theory. As a result of Greenshield's linear relationship theory between speed and density. So Greenshield has given one more expression. Are you remembering it? One more expression he has given. V is equal to Vf minus Vf into K by Kj. Correct? So the speed at any time, some V, or I can write this some U. Okay? The speed at any time U is equal to Vf minus Vf into K by Kj. Vf is the free flow speed, Kj is the jam density, K is the density at that instant. For which instant, in which instant I want to find the average speed of the stream, that instant, what is the number of vehicles per kilometer? That is K and U. So if we are using this equation, we can find out the speed at any instant. That expression is also given by Greenshield, and it is one of the very important equations in transportation engineering. Okay, you have to study that equation, and this is another equation which is very important in transportation engineering from gauge point of view. Fine. So we already know there is an equation like this, and the given expression is U is equal to 80 minus 0.8 K. So whether it looks like same? Yes, it is. Correct? So by comparing those two equations, the standard equations given by Greenshield and the given expression, what you are understanding? This Vf is corresponds to 80. Correct? So directly I can write Vf will be equal to 80. See how we have find out 80 in this condition. First we assume that K will be almost equal to 0. Then we have substituted finally we got 80. Before that, you should know you have to take those conditions. At free flow condition, k is equal to 0, then we have to substitute and find out the value of Vf. But if you are remembering that expression, directly you are getting the value of Vf. Now, so the minus is common, and what all terms are common? This k is there also. Okay, so that also common. Now what is remaining? Vf divided by Kj I can equate to 0.8. Correct? Vf divided by Kj I can equate to 0.8. So Vf I already got it as 80. Now what will be Kj? Kj will be Vf divided by 0.8. Correct? So 80 divided by 0.8. So directly I am getting Kj equal to 100. See, finally here we got Kj equal to 100. So here directly we are getting by comparison. Okay. So 80 I got, Kj is equal to 100 I got. Now I can use this equation. Qmax will be equal to Vf into Kj by 4. What I am getting? 2000 vehicles per hour. Okay. Since they have mentioned that speed is in kilometer per hour and density will be in vehicles per kilometer, the value will be in vehicles per hour directly. Okay. So by comparing, you can decide in whichever way you feels comfortable and whichever way you think you can solve the question fast, you can proceed in that way. Similar questions has been asked in GATE exam, and this concept, this equation and that final equation as per green shield, it is repeatedly asking. So it is very important equation. So once you know that equation, that method will be very simple. Okay, using that equation you can solve lot of problems. Various types of questions will be asked. So once you know this equation, those questions are simple. Okay, but you should know what is Vf and what is Kj and what is U and what is K. K is the vehicles per kilometer corresponds to that instant. Okay, so finally you will get Qmax. Simply we will getting Vf and Kj. Okay, so I hope you have understood this concept, and I am recommending you to proceed in that way by hearting that final equation also, that expression given by green shield. Okay, just go through the solution once again and understand what all things we have done. Just go through the solution. Okay, hope you understood. So what all things we have done? So in the first method, the concept was, whenever we want to maximize a quantity, we will differentiate it with respect to the variable and we will equate it to 0. That concept you can use everywhere. Okay. So in the method 2, we have used the expression for Qmax. Very important expression, you should remember that. Vf into Kj by 4. Now we found out what is the value of Vf and what is the value of Kj. Vf is the speed in free flow condition, so that density will be almost 0, and in jam condition speed will be almost 0, and we have found out the value of Kj and we have substituted in the equation. So in the shortcut method, if you remember this equation, directly you are getting the value of Vf and Kj. No need to check any condition. Okay, no need to check any condition. Directly you will get the value of Vf and Kj once you remember that equation. And I am repeating, remember that equation. It is very important. If you are remembering that equation, you can solve those questions, such type of questions very easily, and some other questions also may be coming from that equation. Okay, so hope you understood that question and the solutions. Now we will move on to the next question. So let's read the question. In a two-phase signal intersection, the normal flows on the two approach routes are found to be 500 PCU per hour and 300 PCU per hour respectively. The saturation flows are 1600 PCU per hour on each road, and the total lost time per each phase is 8 seconds. The effective green times in seconds for the two phases will be dash and dash respectively. Okay, they have given 4 options also: 26, 21, 26, 16, 36, 21 and 36, 16. Okay, so read the question once again and check what we have to find out, and for that what all data they have given. Okay, read the question carefully. They have given that it's a two-phase signal intersection, and they have given for each phase what are the normal values of flow, and also they have mentioned the saturation flow is same on both phase, it is equal to 1600, and they have also mentioned that the lost time per phase, each phase, both phases are equal, it is equal to 8 seconds. And finally they have asked what is the value of effective green time on both phases. Okay, so in order to solve that question, primarily we have to know what is the equation for finding out the effective green time, correct? So what is the equation for finding out the effective green time? I am representing it as G. Okay, so G is equal to Y divided by capital Y into C naught minus L. Correct? What is that small y? It is the ratio of normal flow to saturation flow. Normal flow to saturation flow, correct? The ratio we call it as small y. Okay, so how many phases we are having, that many ratios will be having. Understood? If it is a two phase, then we will be having two ratios, because we are having two set of normal flow and saturation flow. If it is a three phase signal, three ratios we will be having: Y1, Y2, Y3. If it is a four phase signal, Y1, Y2, Y3, Y4. Okay, so here they have mentioned that it's a two phase signal, means we will be having two ratios, Y1 and Y2. Okay, same thing, this will be the normal flow ratio, normal flow, I am representing it as Q. Saturation flow, yes, so Y1 will be Q by S ratio in phase 1, and Y2 will be this Q by S ratio in phase 2. Okay, so effective green time for the first phase is Y1 by capital Y into this value. Effective green time in the second phase is Y2 by capital Y into, I can represent this Gi and Yi. Okay, seems to be more clear. Fine. Now, what is capital Y? It is the sum of these ratios, correct? It is the sum of these ratios. If it is a two-phase signal, in like this case, we are having two values, two ratios. So in this case, it will be Y1 plus Y2. Okay, that is capital Y. What is C naught? C naught is the optimum cycle time, and capital L is the lost time. Lost time per cycle. See, this is very important. It is the lost time per cycle. So most of the time students may not be noting the definition exactly. Okay, it is the lowest time per cycle. I will tell you why it is important. Fine. So C0 is the optimum cycle time. Fine. Now check whether they have given the value of y1 in the question. No. Y2, that also no. Lost time per cycle, no. C0, that also they did given. Correct. So they haven't given any value directly, but they have given what is this value. I'm representing as Q1, S1, so Q2, S2. So these two values and these two values they have given. And also lost time, read the question once again. Lost time per each phase that they have given. What is that value? 8 seconds. Lost time per each phase is 8 seconds. So how many phases we are having? 2 phases in this question. Correct? So lost time per cycle will be how much? 8 in the first phase. They told that in both phases it is 8. So second phase also 8. So what will be the value of L? 16 seconds. Okay, very important. If you are just studying the definition as lost time, then you will take L is equal to 8. So don't make mistake. It is the lost time per cycle. So if they are giving the lost time per phase, and if they are telling that in each phase it is same, then you have to multiply that value into the number of phases so that you will get the total time per cycle. If it is a 2-phase signal, means what? In a cycle, 2 phases are there. 4-phase signal means in a cycle, 4 phases are there. Okay. Now, how to find out the value of Y1? The normal flow divided by saturation flow in the first phase. So check the question. What they have given? They have given that the normal flows are 500 and 300 respectively. So Q1 they have given it as 500, and in Y2 they have given it as it is 300. Now I want to know what is S1 and S2 saturation flow. They have given it as 1600 on both phases. Correct? So 1600, here also 1600. See, both are PCU per hour. It can be expressed in vehicles per hour or in PCU per hour also. Correct? So we'll get a ratio here. There is no unit. So 2 ratios I have got. Okay? Let it be there. What is capital Y then? 500 by 1600 plus 300 by 1600. So what I'll get? It will be 800 divided by 1600. We will get 0.5. Okay. So in the main expression, this value I got, this value also I got, this L value also we have obtained. Now what is remaining? We want to find out what is the value of optimum cycle time. Okay. What was actually optimum cycle time? It is the cycle time at which the overall delay, the average delay of the cycle is minimum. Okay. So how to find out the value of optimum cycle time? How to find out the value of optimum cycle time? Very important equation in transportation engineering for GATE exam. Plus 5 divided by 1 minus y. Very important equation from transportation engineering from GATE point of view. Okay. C0 is equal to 1.5 L plus 5 divided by 1 minus y. Okay. So it is optimum cycle time. We don't have separate values. For a cycle, what is the length of time? What is the value of cycle time? So 1.5, what is the value of L? Lost time per cycle, it is 16 plus 5 by 1 minus, what is the value of capital Y? The sum of 2 ratios. I am getting 0.5. Okay. So if you are substituting, you will get a value of 58 seconds. Okay. So I have obtained what is the value of y, capital Y, C naught, L, everything I got. Now direct substitution only, correct? So that I should know what is the exact value of y1 and what is the exact value of y2, correct? So you need those values in order to substitute in effective green time. Okay, so we got all these things, everything we obtained. Now I can find out what is the effective green time in first phase. Effective green time, I am representing it as G. In first phase, what it will be? Y1. What is Y1? 0.3125 divided by capital Y into C naught minus L. What is C naught? 58 minus 16. So this is effective green time for the first phase, correct? What will be effective green time for the second phase? Only changes here, this will change, the Y value, the ratio will change. What is that? Y2 value 0.1875. Here only change is coming, remaining things are common for both, no? So 0.5 into 58 minus 16. Okay, so if you are calculating, you will get 26.25 seconds, and here you will get 15.75 seconds. Okay, so check the options. From the options, which can be the correct answer? They have, as per the options, they have given 26 and 36 for the first one. So I can approximate it as 26 seconds. And the second part, they have given 21 and 16, correct? So I can approximate it as 16 seconds. Okay, so 26 and 16. What is the correct option? 26 and 16. So you will get option B as the correct answer. Okay, so for the first phase 26 seconds, and for the second phase 16 seconds. Understood? So just go through the solution once again and check what all things we have done. Check it properly, what all things we have done, and understand the concept carefully. Okay, so first what we have done, we have taken the normal flow to saturation flow ratio for each phase. For each phase we have found out the normal flow to saturation flow ratio, and we have taken the sum to obtain capital Y, correct? One more important thing, lost time per cycle we have to find out. It is not per phase. So if they are giving phase, you should read the question very carefully. If they are giving the lost time per phase, we have to convert into lost time per cycle and substitute for capital L. Okay, and what is the value for C naught? The optimum cycle time. Very important equation from gate point of view. 1.5 L plus 5 divided by 1 minus Y. Y is the ratio, L is the lost time per cycle, direct substitution. Okay, so you will get C naught is equal to 58 seconds in this question, and only this part will change for each phase. If this part will be common for all the phases, only changes what is that ratio of normal flow to saturation flow for that particular phase. Okay, so you will get the answer. Fine. So if they are asking the effective green time, suppose most of the time they will be directly giving you the optimum cycle time. Otherwise, they can directly ask you what is the optimum cycle time only. They will not extend the question till here. Okay, so you will get 2 marks just to find out what is the value of optimum cycle time. Lot of times they have asked that. So that equation is very important. 1.5 L plus 5 divided by 1 minus Y. Okay. So hope you have understood the concept. Now we will move on to the next question. Okay. Let's read the question. The design speed of a two-lane road is 80 km per hour. Okay. The off-tracking value on the curve is found to be 0.082 meter. What should be the extra widening provided on this curve? Okay, read the question once again and understand what they have asked. They have asked what is the extra widening required. Okay, and for that they are told that the design speed is 80 km per hour and it is a two-lane road. Fine. And the off-tracking value also they have given, it is equal to 0.082 meter. Okay. So in order to solve this question, we should know what is the equation for extra widening of the road. Correct? Where we will give extra widening? On the curves. Correct? On the horizontal curves we will give extra widening. What are the two reasons why we are providing? Okay, two reasons for extra widening. What are those? One is due to off-tracking, due to the mechanical features of the road, of the vehicle. What is that feature? The rigid wheelbase of the vehicle. The back tires will be rigid. They will not follow the front tires. That phenomenon is calling it as off-tracking. Correct? So, because of that off-tracking, we have to increase the width of the road. What is the next reason? As drivers, they will be having a tendency to keep more sidewise distance when they are moving on horizontal curves. Correct? If it is a straight road, they will be moving like this by keeping a small distance only sidewise. But whenever they are moving on a curve, what they will do? Both the drivers will be having a tendency to keep more distance sidewise so that they may be feeling that there is a chance of sidewise collision. Okay. So because of that psychological tendency, also we need more width of road. Okay. So what was the total widening? The total extra widening is what? The extra widening due to mechanical reason is called mechanical widening plus the widening we need due to psychological tendency. Correct? So it is called psychological widening. Okay? So two reasons. So the sum of mechanical widening and psychological widening will be the total extra widening. Correct? So you should know what are the equations corresponds to each one. It is what? The number of lanes into off-tracking. Number of lanes into off-tracking value plus V divided by 9.5 root R. Number of lanes into off-tracking value plus V divided by 9.5 root R. Listen one thing, this V will be in kilometer per hour and this R will be in meter. Finally, you will get some value in meter. Okay. So what is off-tracking value? That you should know. It is L square by 2R. Off-tracking value is L square by 2R plus the same equation V by 9.5 root R. Okay. Now, what are each terms? N is the number of lanes. R is the radius of the curve. V is the design speed. Okay, everything is done. L is there. What is L? It is the length of wheelbase or length of vehicle. Okay. length of wheelbase, or sometimes it is also called length of vehicle. Okay, so if you are having everything, direct substitution and find out the value. Okay, so check whether they have given what is the number of lanes. Yes, they have given. No, what is that? N is equal to 2. That they have given. Fine. L square by 2R, which is nothing but off tracking. So no need to substitute anything. Why? They have directly given what is off tracking. Correct? How much it is? 0.082. Okay. So this much meter will be the mechanical widening. The widening we required due to the off tracking. Correct? Now we want to find out what is the width required, extra widening required because of the psychological reasons. Okay. So whether they have given any design speed value in the question, yes, they have given. No, they have given it as 80 km per hour. Remember, you don't have to convert into meter per second. It is in kilometer per hour only. Fine. Divided by 9.5 root r value. What is the radius value? They haven't given in the question. Then what we will do? We are having a hint. What is that hint? They told that the off tracking value is 0.082. That is L square divided by 2R is equal to 0.082. So in this expression R is there. So we can find out the value of R. So L square divided by 2R is equal to 0.082 meter. Correct? But if we want to find out the value of R, we should know what is L. Whether they have given any length of vehicle in the question? No. Whenever they are not giving, what is the hint? There will be a value as per IRC. Okay. So the average length of wheelbase as per IRC is how much? It is equal to 6.1 meter. Average length of wheelbase as per IRC is how much? 6.1 meter. Okay, very important. Most probably they may not be giving the value. So if they are not giving, we have to take 6.1 meter. Okay, it is the average length. Some vehicles will be more length, some vehicles will be less length. Okay, so sometimes in the question, if they are giving some value, suppose they are giving length of vehicle is 5 meter or length of vehicle is 6 meter, then we have to take as it is. Whatever value they are given in the question, you have to take as it is. It may be 5, it may be 5.5, whatever. If they are not giving, then as per IRC, it is average value is 6.1 meter. Then that value we have to substitute. In this question, they haven't given any value for the length of wheelbase or length of vehicle. So what we have to do? We have to substitute 6.1 for L. Then what I will get? R is equal to 6.1 square divided by 2 into 0.082. Correct? Then what will be the value of R? You will get 226.89 meter. Okay? If you are finding out 226.89 meter. Now this value we can substitute here. Correct? 226.89. So now we have obtained everything. Correct? So one more thing, listen carefully. Again, you don't have to find out. When you are finding out, if you are remembering that 6.1 value, don't try to calculate like 6.1 into 6.1. Don't need to calculate. Why? Always check that off tracking is already given in the question. Correct? That's how we have find out the value of R. Okay, so direct substitution. So this is the mechanical widening. This is psychological widening. So you will get 0.72 meter. Okay, so this is the total widening required. Sometimes they can ask you separately also. What is the mechanical widening required? What is the widening required due to psychological reasons? So like that also they can ask. So total value is 0.72 meter. That much widening we required. So as per the given options, what will be the correct answer? Option B, correct? Whenever that exact value is not there, we have to select the nearest value, correct? So 0.75 meter will be the correct answer. So what is actually means it? 0.72 meter. What it actually means? See, we are having a straight road and a curve. Okay. So this is a two-lane road. What is the width of a two-lane road? 2 into 3.5. So 7 meter. So here the width will be 7 meter. Whenever we are going to the curve, we have to increase the width by 0.72 meters. So we will increase the width here. Okay. So we will increase the width here, and after the curve, finally it will be like this only. Okay. So what is the width of the road here? It will be the existing width 7 meter plus the extra widening we have provided. So as per the question, as per the options, 0.75 meter we have to provide. So the width of road on this curve will be 7 plus 0.75. We will get 7.75 meter. So that will be the width we are going to provide on this curve. Okay. So go through the solution once again and understand what all things we have done. Okay. Go through the solution and understand what all things we have done. Always remember that value of average length of wheelbase. And whenever they are asking the total extra widening, it is the sum of two. So they may not be asking the total every time. Sometimes they can ask you what is the extra widening required due to the mechanical features. Means only this part. Sometimes they can ask you what is the extra widening required due to the psychological reasons. Okay. The psychological tendency of the driver to keep more distance sidewise when they are moving on a road. Okay. So that is extra widening due to psychological reasons or psychological extra widening. Fine. So I hope you have understood that concept. Now we will move on to the next question, which is the last question of this session. Fine. Now this question we will discuss from railway engineering. Okay. When you are comparing the weightages for railway compared to highway, it is less. Okay. But the thing is, in railway the portion is very less. So that if you are studying less portion, definitely you will get 1 or 2 marks. Okay. Highway is comparing to railway and airport and all. Highway is somewhat lengthy. Okay, as per our syllabus. And airport also it is by comparing it is less weightage. Okay. So now I will discuss one important concept from railway engineering. Okay. So if they are asking question from railway engineering, most probably it will be from this concept only. Fine. Now read the question. For a 2-degree curve on a broad gauge railway track, a super elevation of 5.18 centimeter is provided. Okay. If maximum cart deficiency is allowed, what will be the value of maximum possible speed on this track? Okay. Read the question carefully once again and understand what is asked. They have given that it is a 2-degree curve and it is on a broad gauge track and a super elevation of 5.18 centimeter is given. So actual super elevation which is provided on the track is 5.18 centimeter. Okay, and a maximum count deficiency is allowed. Fine. Then what will be the value of maximum possible speed on this track? Okay, so we have already studied the super elevation concept in highways. Okay, what was the equation? E plus F is equal to V square by Rg, or capital V square divided by 127 R. That was in highways. We are having some sub concepts also. Okay, in railways, the equation for super elevation is E is equal to G into V square divided by Rg. What is this G? G is nothing but the gauge length. Gauge length. V is speed in meter per second. R is the radius and G is the acceleration due to gravity. So here also definitely the speed. This is what speed? Average speed of the train. Definitely the speed of train will be expressed in kilometer per hour only, correct? So V will be in kilometer per hour. So I can also write it as capital V square by 127 R. So in this expression, V is in kilometer per hour. Okay. So this is the equation for super elevation in railways. Now what is that gauge length? It is the clear spacing between two rails of a railway track. G is equal to 1.67 meter for a broad gauge. So for a meter gauge, what it will be? From the name itself, 1 meter, and 0.762 meter for a narrow gauge. These values you should by heart. But since they have recently introduced this concept, most probably they will be asking questions regarding broad gauge only. Okay. So for broad gauge, what it is? 1.676 meter. I recommend you to study everything. See, this 1 meter is obviously it will be 1 meter because it is a meter gauge. So only this value also, if you can by heart, you can by heart. Fine. So must you should by heart this 1.676 meter. Okay. Now we can substitute the value of G. We can substitute the value of R. Fine. Then what is this V? It is the average speed. Okay. So better I should write it is the average speed of vehicle. Vehicle means in this case it is train. Okay. So we know on the same track fast trains will be going. Comparatively less speed trains will be going. Correct. We are having some fast moving trains also, no? But whenever we are providing the super elevation, whenever we are raising the outer edge of the rail with respect to inner edge, regarding the average speed only we will decide what should be that height. Okay, we will not be providing for the maximum speed. We will be providing for average speed only, which means for some trains it is giving only less than what is required, and for some other trains they are getting some advantage, they are getting enough super elevation. But for some fast moving trains, see, this V is what? Average speed. Based on this average only we are giving super elevation, and for some higher speed trains they are actually getting less super elevation compared to what is required by them. Correct? So actually what is happening? They are getting a deficiency in super elevation. What is the other name of super elevation? Can't. Correct? Super elevation is also called can't. So a deficiency in super elevation, which is also called can't deficiency, is happening for such fast moving vehicles. Okay. So for the maximum speed, if they want to take, the superelevation should be somewhat higher, but we are not giving that higher superelevation because we are providing the actual superelevation based on average speed only, which is less than the maximum speed, correct? So actually what is happening, the superelevation which is required for the maximum speed, I am calling it as some theoretical value. Okay, this is not the actual value we are providing, it is the theoretical value which is needed, which may be needed for maximum speed of train. It is equal to what? The actual superelevation we are provided plus the Kant deficiency. Correct? From this theoretical value, there is a deficiency for the Kant and we are providing this E actual. So I can write it as E actual is equal to E theoretical is equal to E actual plus Kant deficiency. This E theoretical we are finding for maximum speed and this actual is corresponds to average speed. Correct? So what is the equation for G? What is the equation for superelevation? It is G into V square divided by 127 R. So here, if I want to write theoretical, this V should be the maximum speed. Okay. So similarly, what will be E actual? G into V square divided by 127 R, where this V is average. Understood? Plus whatever be the Kant deficiency, that value. Fine. Now, so this is the equations and fundamental relationship between E theoretical and E actual. Fine. Now check the given data. What all things they have given? They have mentioned that it's a 2-degree curve. Okay, fine. Now they have mentioned that a super elevation of 5.18 centimeter is provided, which means the actual super elevation provided is how much? E actual is how much? 5.18 centimeter. The unit also you have to note, 5.18 centimeter. Fine. See, if you are substituting the value here, it is what? The gauge length. Gauge length is in meter. Correct? R also we are substituting in meter. And we actual, if it is substituting in here, it is meter per second. And we are taking care of this G and we are converted into kilometer per hour. Fine. Now 5.18 centimeter. If I want to use this equation, it should be in meter. Correct? So it will be 0.0518 meter. So let it be there. So this value is already given as 0.0518 meter. Fine. Now what they have asked? They have asked something from this. What they have asked? They have asked what is the value of maximum speed. Correct? So if I want to find the maximum speed, I want to find this right hand side portion and I can equate to this value. Correct? Then I can find out what is Vmax. Understanding? So this value they have already given. It as 0.0518 plus. Now I want to find out what is this Kant deficiency. Check in the question whether they have given any value for Kant deficiency. No, they haven't given. But they have mentioned that maximum Kant deficiency is provided. So, if you know what is the maximum value we can provide, it is a limit, correct? So, if we know what is the limit, then we can substitute. Okay? So, for that, we should by heart a table for maximum current deficiency. What it means? See, for maximum speed, this value is higher, but actually we are providing some lower value. So we are providing some deficiency, no? So what is the maximum deficiency we can provide? What is the maximum decrease? What is the maximum deficiency we can provide? More than that, you shouldn't provide. Okay? So there is a table for maximum current deficiency. So for broad gauge, we are having some value, for meter gauge and for narrow gauge also. At least you should by heart what is the value for this broad gauge. Fine. So here also we are having two categories, which is speed is less than or equal to 100 km per hour, and if the speed is greater than 100 km per hour. Okay. So speed is greater than 100 km means what? It is a high speed track. So generally they will not ask that, but still I will give you the value. At least you should remember the first column, 75 centimeter, 50 centimeter, 75 millimeter, 50 millimeter and 40 millimeter. And if it is a high speed track, we should provide 100 millimeter. We will not provide high speed track for meter gauge and narrow gauge. Okay, so understand that concept. So the maximum value, at least you should by heart this. Okay, because most probably they will be asking questions based on broad gauge only. Okay, so they told that the maximum current efficiency is applied. So what will be the value of current efficiency? See, by default it will be the first case. Okay, by default it will be the speed will be less than 100 km per hour. Suppose if they are mentioning it is a very high speed track having design speed more than 100, then only we have to take 100 millimeter. Okay. So here by default we have to check the first column. So what will be the value of current efficiency? 75 millimeter. So I have to convert into meter, correct? So 75 millimeter is 0.075 meter, correct? So I got some value on the right hand side. Now I can equate to the left hand side. Fine. So I am rubbing this portion. Hope you have noted this equation. It is already here also. Fine. So if you are taking the sum, you will get 0.1265. 0.1265 meter. Okay. So that is equal to what? G into Vmax square divided by 127 R. So what is the value of G? 1.676 meter. Correct? Then Vmax square divided by 127. What is the value of R? Whether they have given anything, just check. The radius of the curve is dash. No, they haven't given. Correct? So 99% in railway engineering, they will not give the value of radius. Why? Because in railway, generally we represent a curve with its degree. Okay, they will mention it's a 1 degree curve, it's a 2 degree curve, it's a 3 degree curve, like that. So what is the concept of degree in a curve? If it is highway also, we can represent it in degree also, but mainly in railways, this concept of degree, it is very significant. Fine. So actually what is degree of a curve? It is 1720 divided by radius. Correct? So degree is equal to 1720 divided by R meter. So R I can write it as 1720 divided by d degree. Correct? So here since they haven't given the value of r directly, I can substitute r as 1720 divided by, what is the degree given in the question? 2 degree, correct? So 2. So actually speaking, what will be the radius of this curve? It will be 1720 by 2, 860 meter, correct? So instead of giving the radius of the curve is equal to 860 meter, they have given that the degree is this much. So they are incorporating lot of concepts into one question. Okay, they may be. It is not a gate question. I am giving a model of gate question. This like this they can ask. Okay, so that they can incorporate lot of concepts from railway engineering and put it into one question. Fine. Now, see everything we got. What is remaining? Vmax. Correct? This is what they have asked. What is the maximum speed a vehicle can take? Correct? So if you are taking everything there, finally we will get Vmax is equal to 90.9. Which unit? Meter per second or kilometer per hour? It is in kilometer per hour, correct? So what is the maximum speed? It is 90.9 kilometer per hour. Okay? Always check the unit also. If we are using GV square by RG, then we will be in meter per second. If you are using G capital V square by 127 R, then we will be in meter per second. So we have used this equation. So directly we are getting in kilometer per hour. Okay. So just go through the solution once again and understand the concept. One of the main concept is the theoretical super elevation will be equal to the actual super elevation which is provided on the ground plus the current deficiency. Okay, and sometimes they can give you the current deficiency value directly, like some 70 millimeter, like that they can give. Then 1070 you have to substitute. Otherwise, they can tell you that maximum value of current deficiency is provided. Then we should know this table. At least you by heart the first row. Okay, for broad gauge. Fine. So by default it will be the first column. Means it is not a very high speed track. So 75 millimeter. Always check the unit also. Okay. Check the unit because unit is very important in this case. Okay. So substitute it. Finally, from this expression we are getting something in meter. Okay. So is equating it. And finally we are getting the value in kilometer per hour. One more thing. Most of the time they will be giving the value of actual super elevation in millimeter or centimeter only. They will not give in meter. So always check when you are substituting, check the given unit also. Don't substitute it as 5.18 here. Okay? Always substitute in meter only and proceed. Fine? So just check the solution once again and understand the concept. So this is the first one. Theoretical value of super elevation is actual super elevation plus current deficiency. So what is the difference between theoretical super elevation and actual super elevation? In actual super elevation, we are considering or we are finding the value for average speed. For theoretical super elevation, we are finding it for the maximum speed, maximum permissible speed. Okay, so always theoretical super elevation will be more than actual super elevation. Okay, and also you should by heart what is the maximum current efficiency. Maximum value we can give. Okay, at least you by heart for broad gauge. Fine, it is 75 millimeter and 100 millimeter. Unit also very important. And whenever you are substituting, the value you are getting from the equation is in meter. So you have to equate that value into, you have to express in meter. One more important concept, the degree of curve is equal to 1720 meter divided by R. 1720 by R. R you have to substitute in meter. Okay. So you will get the degree. So when that concept is important, when they are not giving the value of radius, you have to find out by dividing that degree by 1720 divided by the degree of the curve. Okay, like that you will get the R value. Most probably they will not give the value of R. So remember that concept also. Fine. So hope you have understood that particular problem. Okay. So far we have discussed 8 questions, correct? So we have covered almost important concepts of transportation engineering from GATE point of view. Fine. So if you are solving such problems, so we have covered a lot of concepts. So the one particular question may not be asked for 2 marks. Okay. I was giving you the questions which covers most of the portions of transportation engineering. See, suppose take the example of this last question. If you are solving this question, you are getting lot of concept. One is what is the theoretical superelevation, what is actual superelevation, what is content efficiency, what is the maximum value of that, how to relate that, what is the degree of the curve, correct? So lot of concept we have seen. Maybe in the examination they may be asking a part of this question. Directly, theoretically they can ask. For 1 mark, what is the content efficiency? Correct? So a part of this question can be asked in GATE exam. Okay? Like that we have solved a lot of questions. Fine? So always check whenever a rule is there as per IRC, you have to check that also, like super elevation and all. Fine? Compensated gradient also we are having some limit. So check those concepts. Okay? So I hope this session was useful for you, particularly for students who are going to write 2019 GATE exam. It will be beneficial for you to revise, correct? Once you studied and if you are attending the session, it will be very beneficial for you to revise the concept of transportation engineering. Okay, so try to solve more questions, as many number of questions possible to solve. Practice that. So as many times you are practicing, you will be more confident in the concept. And also equations, we are having a lot of equations. Try to write in one diary or somewhere and try to revise it as many number of times possible. Okay, only equations. So in transportation, what advantage you are getting compared to other subject is we are having simple equations only. And once you studied the equation, directly 2 marks you will be getting. Okay, so by mucking up the equations is very important. So try to write it in a diary and try to revise it as many number of times possible. At least once in a day you should revise all the equations. Once you are doing that, then simply you will get minimum 8 marks. Almost 9, 10, 11 marks question will be coming from transportation engineering. If you are mucking up all the equations, at least you will get 8 marks. Okay, so try to work on whichever subjects you are confident. Try to work on it and try to solve maximum problems. And if you are weak in some subjects, no problem, just study the basics only. Don't go too deep if you are weak in such subjects. And transportation is, I think it's comparatively easy subjects. So try to focus more questions. Easily you are getting 10% of marks out of 100. Correct? So try to work on more problems. And so I hope through these 8 questions we have discussed, we have covered almost significant portions of transportation engineering. And you could brush up lot of concepts. Okay, so I hope this session was useful for you, and kindly give us the feedback. Thank you.